Get ready for a massive breakthrough in Martian exploration. NASA's Curiosity Mars rover just completed a brand new drilling into a large target, and the team has pulled off an incredible maneuver to free the drill from the Atacama drill hole. Deputy Principal Investigator Michelle Minetti detailed the careful dance of robot arm motions that were meticulously planned to free Curiosity's drill, confirming the health of the arm and drill before wheeling the rover toward its next big objective. This is a monumental step forward in understanding the geology of Mars, and you won't want to miss the details of this successful operation. At 500 times the performance of current space processors. This technology promises to allow rovers to make real-time decisions and tackle complex AI challenges out in the vastness of space. And finally, the universe meets Hollywood in a spectacular collision of science and fiction. The Mandalorian and Grogu just depicted real ion propulsion technology used by NASA's Psyche spacecraft during a Mars flyby. We break down how the Hall effect thruster's xenon exhaust plume is a perfect match for the film, and explore the surprising material science parallels between Beskar armor and real-world composite materials. Don't miss this deep dive into the technology that is bridging the gap between science fiction and current aerospace reality. Subscribe to our newsletter for more engaging content, and check out EarthSnap today. NASA's Curiosity Mars rover has successfully completed a new drilling operation into a large target after overcoming a mechanical hurdle. The incident occurred when the rover's drill became lodged in the pre-existing Atacama drill hole. Engineers executed a precise sequence of robot arm movements to carefully free the drill bit from the obstruction. Michelle Minetti, Deputy Principal Investigator of Curiosity's Mars Hand Lens Imager, MAHLI, detailed the meticulous planning involved in this maneuver. Following confirmation that the drill and arm were functioning correctly, Curiosity was repositioned for the new drilling site. Minetti affirmed the ongoing commitment to the mission, stating, "Our Martian exploration continues undaunted." This successful operation follows a previous challenge where the rover encountered a stuck drill bit on Mars. The team sought to sample a rock and discovered a similar specimen nearby, prompting a calculated decision to proceed with the new target. The images captured by Curiosity's front hazard avoidance camera on Sol 4897, May 16, 2026, document the rover's progress in this continued pursuit of Martian geological data. Buzz Aldrin performed a private communion on the lunar surface shortly before his first step, an event that was deliberately omitted from the live broadcast, a decision rooted not in religious suppression, but in institutional risk management. The popular narrative frames this as a story of suppressed faith, but a closer examination reveals a complex administrative reality concerning NASA's navigation of an active Establishment Clause lawsuit. The ceremony occurred during a scheduled rest period between the Apollo 11 landing and the Extravehicular Activity, EVA. Aldrin used personal items, including a communion kit provided by his pastor, to perform the ritual. He read a passage from the Gospel of John silently while Armstrong observed without participation. NASA's decision to keep the communion off-air was tied to legal exposure. 6 months prior, the Apollo 8 crew's reading of the Book of Genesis during their Christmas Eve broadcast had prompted a lawsuit filed by Madeleine Murray O'Hair against NASA, challenging the broadcast under the Establishment Clause. This pending legal challenge created a risk that the Public Affairs Office was unwilling to authorize during the high-stakes lunar mission. The distinction is crucial. NASA forbade the announcement, not the act itself. Aldrin later acknowledged the legal context, suggesting the agency's request was procedural caution rather than ideological opposition. The broadcast announcement was carefully neutral, asking listeners to contemplate the preceding hours and give thanks in their own way, avoiding specific scripture or deity references. While private observance continued, with astronauts permitted personal items and devotional practices, the boundary for public broadcast was redrawn by the legal climate. The lunar communion proceeded, documented later through personal accounts, church archives, and historical records, rather than through the live feed. The incident ultimately serves as a case study in how federal agencies manage the integration of personal expression within the constraints of constitutional law during unprecedented missions. NASA is developing a revolutionary, radiation-hardened processor that could enable spacecraft to operate independently, drastically changing future deep space missions. Current space technology relies on aging computer chips that are slow and vulnerable to the harsh environment of space, leading to delays in data processing and reliance on Earth-based control. The new project, stemming from NASA's high-performance spaceflight computing project in collaboration with Microchip Technology, Inc., and the Jet Propulsion Laboratory, aims to create a processor capable of making real-time decisions, solving problems autonomously, and handling massive data streams onboard. Space presents extreme challenges for electronics, including intense radiation from the sun and deep space, extreme temperature fluctuations, and the need for instant data processing during planetary landings. To counter these issues, NASA has subjected the new processor to rigorous radiation, thermal, and shock testing. Early test results are highly promising. NASA reports that the new chip is operating at 500 times the performance of existing radiation-hardened space processors, exceeding the initial goal of 100 times the computing power. This leap in performance is critical for missions to the Moon, Mars, and beyond. Faster onboard computing will eliminate delays caused by transmitting vast amounts of scientific data back to Earth, potentially allowing rovers to analyze samples or spacecraft to react to hazards without waiting for mission control instructions. Furthermore, the enhanced power could unlock the use of artificial intelligence on spacecraft, a capability currently limited by radiation concerns. The processor is a compact system-on-a-chip, SoC, integrating multiple components into a single, highly durable unit designed to withstand years of exposure far from Earth. Program managers emphasize that this fault-tolerant, high-performing system represents a significant technical achievement. Beyond space exploration, the technology has potential terrestrial applications, with Microchip planning to adapt parts of the system for industries like aviation and automotive manufacturing. This development signals a broader trend. Spacecraft are becoming increasingly autonomous, necessitating computers capable of thinking for themselves as humanity ventures further into the cosmos. The highly anticipated theatrical release of The Mandalorian and Grogu is revealing deep technological and structural parallels to current real-world science and governance, according to a recent analysis. The film's visual elements are reportedly grounded in operational hardware, suggesting a deliberate alignment between fictional technology and the state of the art. A distinctive blue-violet exhaust plume trailing Din Djarin's ship is identified as a visual match for the output of a Hall-effect thruster, a propulsion system utilizing xenon gas ionized by a magnetic field to achieve high speeds. This propulsion system offers a significant efficiency advantage over chemical rockets, with NASA's evolutionary xenon thruster, NEXT, achieving specific impulses far exceeding conventional systems, mirroring the mission profile of the franchise's long-haul travel. Furthermore, the material science depicted in the film finds resonance in contemporary engineering. The Beskar alloy's ballistic resistance aligns with properties found in max-phase ceramics like titanium aluminide carbide, while the forging process is analogized to historical armor-smithing traditions that encoded cultural knowledge into material form. The photorealism achieved on set, utilizing ILM stagecraft and real-time rendering via Unreal Engine, allows for physically accurate light reflection, where environmental photons interact correctly with actors' equipment, a feat that surpasses traditional compositing techniques. Beyond technology, the narrative structure mirrors complex contemporary issues. The political premise, a republic outsourcing law enforcement to an unaffiliated private contractor in a remote territory, reflects a governance gap currently debated by legal scholars regarding liability and oversight in the commercial spaceflight era. This mirrors the unresolved issue of the Outer Space Treaty of 1967, which was not designed for commercial entities like SpaceX, highlighting a structural parallel between the New Republic's reliance on contractors and the current legal vacuum concerning private space operations. Finally, the intergenerational conflict embedded in the plot, Grogu's longevity compared to Din Djarin's lifespan, is framed as a serious political philosophy argument analogous to issues like climate agreements and sovereign debt, where decision-makers and consequences are separated by generations. The film opens its wide theatrical release on May 22, 2026, positioning it not just as science fiction, but as a commentary on current technological limitations and geopolitical realities.